We're all good on Zoom.
We're good.
Well then, hello and welcome everybody. Welcome to the November edition. I had to think about that word. Of the PVAS monthly program. So we're very excited to have Christian Thomas as our speaker today. And I'll introduce him after a little bit, after I tell you about some PVAS updates. So from the education land side of PVAS, so far this fall, we've served over 1,500 youth in our variety of programs. So that's Turtle Time that happens every month at Cool Spring, followed up by a thing called Trail Trekkers, Friends of the Forest. So that's one of our school programs managed by Amy Thomas. Fourth grade watershed program serving all the schools in the Tri-County area, as well as one of our new program offerings, our Schools Out Day Camps. So this is a photo on the bottom left from our election day camp when kids didn't have school. And then our next one is Thanksgiving week, the Monday and Tuesday of. And we had a really lovely survey coming from one of the teachers. And she said, I had several students who commented that this was the best day ever. And they loved walking through the trails. So best day ever. What a compliment. Of course, this happens through the hard work and dedication from our AmeriCorps service members. And here's a picture of all 6 of them having fun in the canoe there at Cool Spring Preserve. And yeah, they're doing a great job with all these kids, and we're looking to grow the team. So we're currently recruiting for March 2025, where we're going to add a few new educators. Some of them will be ending their service at that time, but we're also going to be increasing the team a little bit. And also conservation positions. So people who are a person who will be leading volunteer work days at our various preserves. So we have an application online. It's on our website right there. And if you know anybody that might be interested in a 6-month position with us in any of those roles, please don't hesitate to give them that information. Real soon, this Saturday, is our birdseed sale. So this is a great way to feed the critters near your home and support PVAS at the same time. So this is at the Sunny Meadows Garden Center in Boonesboro. And if you're planning on this, I also encourage you to check out on our website our monthly programs page. We have a great presentation, if you missed it from a few months ago, about how to treat your windows with a variety of techniques, both DIY and like commercial products, to help keep birds safe. Because of course, when we attract birds close to our windows, there can be more bird strikes near. So that resource, as well as Christian's presentation, when we get it online, are all on that monthly programs page. I wanted to give a brief thank you for everyone that participated in our online auction. We're excited to share that we made over $11,000 from this auction. So thank you. Thank you for participating. And if you got some items, just a reminder to pick them up at your indicated location this weekend or next week. Pretty soon, in the next 2 weeks, Thanksgiving week, we're expecting the annual report and annual appeal will be going to mailboxes. So keep an eye out for that. And yeah, think about if you are willing to support the annual appeal. A few notes about some things coming up soon. Of course, we're continuing with our regular things, like there's the USGS bird walk this weekend. There's a full moon walk tomorrow night. But I want to highlight some things that are a little bit more unusual, some seasonal things. So Thanksgiving break camp, already mentioned that. We're having a number of volunteer work days coming up, and some of them are on weekends, which is a little bit more unusual, and that might mean that more of you are available to do that. So please check that out. Some of them will be removing invasive species. Some of them will be planting trees. In early December, we have the return of Kingfisher Kahoot virtual trivia. So that's led by Master Naturalist Roy Boyle, and this one will focus on geology. So the last billion years. So, you know, brush up on the last billion years before you come if you want to win. We have a few special activities this winter led by PVAS staff. One is an eco-craft workshop, so making some wreaths out of invasive species. And then finally, it's the season for Christmas bird counts. So right now we have 3 scheduled, one for Charlestown, Inwood, and Washington County, and that's approximately mid-December. So that out. Okay, the next monthly program is about dark skies. So it will be a presentation by Jesse Melton, who is a dark sky advocate with the Bolivar Hoppers Ferry Dark Sky Association. And yeah, it will be about dark sky practices for your home and neighborhood, and just other insight from this local organization that promotes dark skies in our area. That'll be pretty cool. And the big thing to know about the next monthly program is at a different location. So we've been here at Hospice for a while, but starting next year, because we skipped December. So starting next year, we're gonna be at the Bird Center, the one that's for Congressional History and Education, which is at 213 North King Street. It'll all be online, but just emphasizing, it's this one with the big rotunda. And so to get to the presentation space, you'll go through the doors at the big rotunda, and then there's a little hall, and then there's this auditorium space. And we'll be set up somewhere between that rotunda and the entrance to the presentation space for our normal social time, having some snacks and all of that. So as long as you go to the rotunda, you should be fine. Okay, so at this point, I would love to introduce Christian Thomas, who is our speaker tonight. So Christian leads SkyTruth's resource extraction monitoring work, both on land and at sea, focusing on surface mining, offshore infrastructure development, and marine pollution events. In addition to applying his background in geographic information systems, GIS, and remote sensing, he has helped design lessons for SkyTruth's educational outreach program. Christian is a native of Shepherdstown, West Virginia, who joined SkyTruth's team after graduating from West Virginia University with a BS in Geography and Environmental Geoscience. When he's not in the office, Christian enjoys travel, intricate board games, and adventuring in the great outdoors. Christian is also a longtime PVAS person, and he's going to tell you a little bit more of that in his presentation. So join me in welcoming Christian. Yay.
Thanks, Sonia. Hi, everyone. I'm Christian, if you don't know me. And I'm a geospatial engineer at SkyTruth. And tonight I'm going to be talking a little bit about how we as an organization use satellite imagery and machine learning to identify and monitor threats to the environment. Before we get into that, I'll just give my PVAS bona fides. So these are pictures of me as a counselor in training at the Yankower site in 2008 or 9, I'm not sure which. After I graduated high school, I worked as a camp counselor for 2 summers, so once after my freshman year as well. And then after I finished my undergrad, I did watershed education with PVAS in 4th grade at Eagle School. Been a really fun. PVAS is a great organization. I was also very fortunate to live at the Cool Spring Preserve with my wife for 5 years, 6 years. And just really grateful to be invited here this evening. And I think PVS does really great work engendering sort of a strong love and appreciation for the outdoors and in our community, especially with children. So thank you for your role in doing that. So this evening's agenda, we kind of got a little bit of run the show here. We'll give you the SkyTruth boilerplate, and then we'll do a remote sensing overview just to describe some of the imagery that we'll be looking at. Some of those details make sense as we go forward. I'll give you a brief background on the origination of SkyTruth, followed by discussing some of our legacy projects, which are not ones that we're actively pursuing at this moment, but I think really speak to the overall ethos of how SkyTruth approaches conservation issues. And then we'll dive into 2 of our ongoing projects, one on land, looking at mountaintop removal mining in the central Appalachian coal fields, and then our work to identify and assess climate impact of offshore development. And then we have Q&A, although I'm not stickler for waiting to the end. So if you have questions that come up in the middle, I'm happy to answer them as they arise. SkyTruth is a nonprofit environmental research organization. We're based here in Shepherdstown, although our team is distributed across the country. And we focus on using satellite imagery to raise awareness about the impact that human activity has on the environment. And one of the key focuses for us is providing our data freely and publicly so that we can facilitate research that helps us understand the impacts of climate change, but also to provide advocates and activists with the tools that they need to better protect the areas that they care about. I always like to start with this picture. This is the first image of Earth that's taken from space. It was a camera attached to a V-2 rocket sent up from the White Sands Missile Range in 1946. Can't really tell a whole lot about it. There's a cloud, maybe. But I think it really helps illustrate how far technology has come. And I think as we go through and you ever start wondering or thinking, maybe these images are a little grainy, just remember it could be like this. So, talking about the types of imagery that we'll primarily be looking at, there's two specific styles of satellite sensor. The first of which is multispectral. And these are known as passive sensors, which means that they're measuring reflected light. So they see the world in the same way that our eyes do. One of the really great things about multispectral data, though, is it provides us information across a wide range of light wavelengths. So we get red, green, and blue, pretty standard. But we also get a lot of great information about near-infrared reflectance, shortwave infrared reflectance, or thermal properties of the landscape. And the reason that those types of data are useful is because it allows us to measure things like vegetation recovery, overall vegetation health, things like that. Really, really helpful for terrestrial applications. And the second type of imagery that we'll be looking at is radar imagery. So this is a satellite image. You can also see our very old logo. It's been updated. But this is a satellite image taken over the Caspian Sea looking at oil infrastructure that the Soviets put in. And one of the things that's really nice about radar imagery is that it's an active sensor. So it actually transmits data, or it transmits a signal and measures the strength of the return. So it's helpful because it can actually look through cloud cover and give us a sense of what's going on the ground, or in this case on the water. And what it does is it looks, essentially, the strength of the return indicates the roughness of what's being looked at. So things like this over here, brighter areas are land. We can see these like very white pixels. Those are actually individual pieces of infrastructure. And we use radar imagery specifically to try and highlight oil slicks. So when oil's on the surface of the water, it creates a very smooth sheen, and that translates to these relatively dark patches. So you're all sensing scientists now. So just touch on how SkyTruth sort of came to be. So SkyTruth was founded in early 2000, and it was founded by a man named John Amos, who was an exploratory geologist. And a lot of his work had him looking at imagery like this to help industry develop. And what we're looking at here is Mount St. Helens about 8 years after the eruption. On the left-hand side is a true color image, like what you can see as you're flying over a plane. The left-hand side. The right-hand side, the red one, that's a false color image where all the vegetation is highlighted in this really red color. And as John looked at imagery like this, he noticed two things. One, you can see the landscape beginning to recover in the aftermath of the eruption. That's sort of seen on the northwest side of the mountain. And then on the eastern or the right side of these images, you see this pockmark formation clearing, and that's all logging that was taking place on public land. And as John looked at images like this over time, he came to realize that industry was really they were the only ones who had access to a lot of this data or who could make use of it. And so he founded SkyTruth with the goal of providing this sort of imagery and this sort of analysis to other environmental organizations to help support their initiatives. And SkyTruth operated in that way for about the first 10 years, largely in a support role for other orgs. But things began to change in 2010 with the Deepwater Horizon oil spill. Sure we all remember it. But this is an image of the platform on fire. And naturally being interested and concerned for the environment and being a satellite image analyst, John started looking at images like this one and realized we had a really big problem on our hands. So this bright area right in the center of the image is all oil sheen on the surface of the water. And then in these little insets, if you can make them out, there's a couple little dots. Those are response vessels. So it doesn't take a lot to realize that something was inadequate here. And as John continued to measure this over time, he came to realize that the estimates that BP was putting out about the severity of the spill likely were not real. So BP's initial spill rate estimate was that 1,000 barrels of oil were being spilled into the Gulf every day. As John tracked the size of these sheens on the surface of the water over the course of days, he came up with a much more realistic estimate of 20,000 barrels of oil per day. And when folks got wind of this guy in West Virginia saying like, hey, I think this oil spill's bigger, they started to take a closer look as well, and ultimately convinced the U.S. government to take a more robust approach to assessing what BP was saying. Spill rate that they came up with was 62,000 barrels of oil a day, and they employed a variety of techniques, including satellite imaging analysis, to come up with that. And the reason this is so instrumental is because ultimately the money that BP was forced to pay was related to the severity of the spill. So if we had been able to stick around with 1,000 barrels, it would have been significantly more detrimental to coastal communities than it was, even with the money that they did pay. And I think that BP really illustrates SkyTruth's role as a watchdog organization, which is sort of how we see ourselves today. We're helping to shine a light on the things that people don't necessarily pay attention to or aren't able to see day to day. And we continue to facilitate and support the work of other advocacy organizations, but this time with a little more robust scientific analysis that we provide to them rather than just image. So one of the other major projects that SkyTruth helped launch was Global Fishing Watch. We'll talk about them a little bit. They're a longtime partner of ours and really do a lot to support our marine work. But this is another project that we launched with Global Fishing, or with Google and Oceana, which had the goal of identifying and showing the impact that commercial fishing has in the world seas. Another instance of shining light on things that have previously been undocumented. This animation here and all these little dots that are showing up, that is identified fishing activity that's been defined based on signals the ships are sending to satellites, telling them where they are, how fast they're going, what direction they're heading. And Global Fishing Watch uses a variety of machine learning approaches to sort of take all of that data, figure out when a ship is just sailing and when they're actually engaged in fishing. So I'm going to shift to talk about two of our legacy projects. They both are on shore, but I think both sort of speak to the same overall problems that Global Fishing Watch and our work monitoring the Deepwater Horizon speak to as well, which is this idea of illustrating things that people aren't paying attention to. So what we're looking at here is a really fuzzy sage grouse and a wonderful pronghorn antelope in the foreground. And in the back, you can kind of make out, something that looks industrial. It's a well pad. And when we're talking about oil and gas drilling, especially on shore, it doesn't look pretty, even in a picture like this where it's fuzzy, but it's hard to tell how severe this really is. And when we're talking about it, it's not really until we zoom out that we get a sense of like the real impact that this sort of behavior, this sort of activity has on the environment. So this image on the right is showing the Jonah oil and gas field in Wyoming. And essentially this growth of the industry fragments landscapes, disrupts habitat. There have been a number of studies using SkyTruth data that have shown there are negative impacts to public health as they relate to living in proximity to these sorts of operations. And so the work that SkyTruth has done around this has been primarily focused on identifying hydraulic fracking in the Marcellus Shale. So mostly in Pennsylvania with some additional projects in West Virginia and Ohio as well. So this is a map showing the output of a variety of mapping projects that SkyTruth launched to identify where these well paths were located. The way that we did this was through a series of crowdsourced image analysis tasks. So we asked volunteers, interns, students at different universities to help us look at images. So look at imagery like this.
Christian, if you want to ditch it, you can.
Yeah, I
I
don't
think
think
we can
we
hear
did.
you. Yeah.
So looking at imagery like this, we essentially asked them to try and identify these little squares on the landscape. And when they did, we asked them to trace them out. We compiled all of that information together, looked for places where everyone agreed, and those were our well paths. Took a long time, a lot of effort. It's a lot faster just to train a computer program to do it for you. So our work mapping oil and gas drilling is really SkyTruth's first foray into machine learning and how we can leverage these technologies to help illustrate pervasive environmental destruction across wide swaths of the country and the world in a way that we can provide that data in close to real time, because that's what we really need to address some of these problems. So again, here's sort of a side-by-side. On the right-hand side, you see these red delineations. Those are essentially what we had our volunteers draw. And then on the left is an early output from the machine learning model that we used, which tried to identify the locations where those sorts of features existed. And it, it gets some of them and it misses some, and it's not perfect, but people aren't perfect either. But I think this is really illustrative of how we try and approach a lot of these problems now. It's very difficult to continue addressing them if we're relying on a staff of less than 20 people, maybe 5 of whom are actually working on image analysis to provide data to everyone who wants it.
Question.
Yeah.
So do you have people help do that anymore, or do you just stick to?
Yeah, so now we don't continue, we're currently not doing any image analysis tasks. I think there's always room, and this may come up later, in machine learning, we need training data, but we haven't launched any new tasks related to creating those delineations. So one of the other projects I want to speak to is our work mapping small scale artisanal gold mining in the Peruvian Amazon. So this image is a Sentinel-2 scene of the Madre de Dios region. What we're looking at here are 2 relatively large areas of pretty intensive clearing of the Amazon that have been the result of small scale gold mining operations sort of in concert. And then it's hard to tell because it's very cloudy in this image. There's some up along this this river here, and this, I think, is a good illustration of how we're synergizing data together to create useful products. One of the primary problems with using multispectral imagery in areas like the Amazon is there's a high amount of cloud cover, which means we only get a certain amount of usable data, and we can't leverage as much of those multispectral bands like the near infrared that can tell us really where vegetation is and isn't. So we're using a combination of multispectral imagery that we clean to try and remove cloudy areas with Sentinel-1 radar imagery. And so again, some mining operations stand out very clearly, this very dark area, because they're relatively flat as opposed to the highly textured surface of the trees, which is what contributes to this really bright look. But in other places like this, it's still not super clear where the mining is. You can kind of make it out if you know what you're looking for. And so what we've done is we found a way to synergize these 2 data sets together to take the best of radar with the available information about where vegetation is from multispectral. And this is a data product that we create and then provide to enforcement agencies in Peru who are working to monitor the legal gold mining, but also to try and identify locations where new and illegal gold mining operations are popping up. And so, yeah, what we're seeing here in sort of this array of yellow to red is the detections that SkyTruth produces every month, detailing how much land has been cleared for mining in this location. Sticking with mining theme, we're going to shift over to work that we're actively pursuing at this moment, which is related to mountaintop removal mining. So, shocker, West Virginia, environmental org, mountaintop mining. But essentially, mountaintop removal mining is, if you're not familiar with it, is an extremely destructive practice by which the tops of mountains are blasted off. All of the debris that is associated with that is then deposited into nearby valleys in a practice called valley fill, and then the coal is extracted. And SkyTruth has been working on this for a while. The first time we really tried to tackle this came about because we were approached by a group called Appalachian Voices, and they were really curious if we could identify where mining was taking place, because the state data sets weren't comprehensive, and the federal data sets weren't comprehensive either. So there's this question of where is the mining, how much is taking place, and how can we show it? And the project evolved since we started that work in 2008 until 2018. We published our first data set showing the annual footprint of mining dating back to 1985. So on the right-hand side here, we're looking at an animation of the Hobet mine operation, which is in West Virginia. And you'll see a couple more images of this because it's been actively mined for over 30 years. It provides a good example of how the landscape changes over time. So again, on the right side of that animation, we're seeing a true color graphic of the mine spreading over time. And then on the left is actually, it's called a near normalized difference vegetation index image. And what this is a ratio of reflected near infrared and red light that tells us where vegetation exists and where it doesn't, and how healthy that vegetation is. So this black area, as it spreads, is the active mining, so the 80s, probably the 90s, and then 2000s. And understanding where this mining takes place is important because mountaintop removal mining is the primary land cover change driver in central Appalachia. So this region is sort of southeast of, or southwest of Charleston. Again, we're showing the sort of the spread in Landsat imagery. And you can see, like, at any given interval, a lot looks like it's been cleared, but it's still difficult to get a sense of how much has been impacted. So here we're going to look at sort of the growth and of detections that SkyTruth has found in the region. As I said, it's the primary driver of land cover change. And one of the reasons it's so important to look at this is because state permit data isn't always telling us the whole picture. So here we're going to see this is the Taywood surface mine. This is SkyTruth's detection, this area that came as the permit. We're able to identify locations where mining activity is taking place outside of permit boundaries. In a case like this, we coordinated with our partners at Appalachian Voices to really dig into this. Turns out mine operators have sort of an allowance to overstep permits as long as it's acceptable. But that sort of data isn't widely available. And so what we're trying to do is focus on providing this to folks so that they can go out and like push for stronger protections or stronger enforcement. And beyond understanding where these mines are located, the really pressing question facing Appalachia is what happens after the mines go. The Surface Mining Control and Reclamation Act of 1977 requires that mined areas be restored to a level that the landscape is capable of, quote, supporting the uses which it was capable of supporting prior to any mining or to higher or better use. And this higher or better use clause is really a point of interpretation. So based on conversations that we've had with folks who live in these communities, there's sort of this expectation that means you took the forest out, you should put it back. You know, it's the neighborly thing to do, to leave things the way you found them. But that's not always how these regulations are interpreted by industry or by the agencies that help determine post-mining land uses. For example, the economic value of the landscape can be higher or better use. Putting commercial land in development may supersede the needs of putting a native Appalachian forest back onto the landscape. And so the work that we've done has been trying to identify where is this recovery happening, to what degree is that recovery successful. So again, the Hobet 21 mine, you can see the area that's been actively cleared. You can see a lot of great forest here. And then this whole section in the middle, I'm not sure how clear it comes across out there, but this sort of lighter green, these are all areas that have been mined in the last almost 40 years. And there's this question of, well, when are they going to look like the rest of the forest? Are they going to look like the rest of the forest? And so we've worked with researchers at Colorado State University, the University of Nevada, and our partners at Appalachian Voices to lead this regional analysis showing what happens to mined landscapes after mining stops. These charts on the right-hand side show the post-mining trajectories across a number of metrics that we look at. Top two is NBR and NDVI. These are essentially measures of how green the landscape is. These are making use of shortwave infrared data along with red. And the bottom graph is the normalized difference moisture index. And we use that to get a sense for like how mature the vegetation is. So if we're looking at a mine and we see high greenness but low moisture, that probably means shrubland, grass, or poor recovery. If we see high greenness and high moisture, that's probably an indicator that something close to a healthy forest is coming back on the landscape. And if you can make it out, generally the trend that we see is for positive recovery, but typically failing to meet the expectation of what a healthy forest for the region looks like. And that's that dotted line across the top of each graph. So again, looking at the Hobet, this area outlined in red is everything that SkyTruth has detected as being related to this mining operation since 1985. The areas of positive recovery, so it's getting greener or it's getting wetter, are outlined in green. But one of the things that we found, which is worrying, is that of the close to 6,000 square kilometers of land in Appalachia that have been cleared for mining since the 80s, less than 10% of that is reaching a level that's consistent with healthy forests across the region. Another aspect of this work that we're currently addressing is what sort of mining operations can we identify pre-1985. One of the major hurdles for our initial work was making use of best available data. The Landsat satellites that we use collected data since the 1970s, but the data from 1974 to 1984 is lower resolution with less spectral information, so it becomes harder to apply our approach to identify these. But we've launched an initial data product that will help address that. And currently, what we're pursuing is identifying high wall mining operations. So high wall mining is another type of surface mining, maybe less destructive generally than what we think of as mountaintop removal mining. Essentially, industry comes in, cuts out part of the hill, leaving this sheer cliff face, extracts coal along the bottom of the seam, and then moves the high wall in or moves down the high wall. The reason that we're looking at this is that high walls are the most expensive pieces of mines to reclaim. And a lot of these high wall operations actually predate the passage of SMCRA, but recent mining industry has revisited older high walls to try and extract even more coal from these sites. And our partners at Appalachian Voices have indicated that there's a serious concern about what they call zombie mines. So essentially mines that are left listed as active, but no longer producing, as a way for operators to avoid legally required restoration. So we're seeing here, this is a high wall, this sort of like linear feature, first mined in 2011, which has remained unreclaimed. And then the way that we identify these features from imagery is we take elevation data, create a slope map. So what we're looking at, essentially a contour map. And this sort of bright red line is the highest slope. That's the detection that we're able to produce. And one of the reasons that it's important to identify these features is it allows us to create reasonable estimates of how much it will cost to restore a mine site. And our partners at Appalachian Voices, again, have indicated there's serious concern about whether state reclamation funds are going to be adequate in restoring landscapes if mine operators fail to do so. The process by which mining operations are listed as reclaimed is a bond release process. So mining operators put money up front to restore the landscape in the instances where they fail to do so. And if that money is released early or before adequate restoration has occurred, states and local communities are ultimately the ones who are going to pay the bill for further restoration, or they're going to be left with environmental disasters in their hands. So enough doom and gloom for the terrestrial world. We'll talk about doom and gloom at sea. So SkyTruth's flagship project at this time is called Cerulean, and it's an initiative that we launched to identify and map the location of chronic oil pollution at sea. And chronic oil pollution typically takes two forms. One of those are leaks from stationary oil infrastructure, just as maybe as a result of catastrophe or normal operations. And another is a practice called bilge dumping, where vessels at sea will wash out wastewater tanks, often with oil, like that have oil in them, and wash that out into sea rather than dispose of it at port. And bilge dumping is an illegal practice, and this is what it looks like. So again, using a radar image to monitor for pollution events, we see this long linear feature, this dark line across the image. That's a bilge dump. And traditionally what SkyTruth did was look for evidence in the news, like something has been reported, or monitor areas where we knew routine pollution events happened. So we would monitor these locations, trying to identify images where we saw features like this and share those publicly. Working with our partners at Global Fishing Watch and the data that they have about vessels operating at sea, we're able to identify many vessels that may be related to these. So ships above a certain size are required to broadcast information about who they are, both as a safety metric for themselves, but also for other ships. You need to know where everyone else around you is going and what direction they're heading. So we use those broadcasts to pair up to these small white dots to try and identify the source. Again, doing this by ourselves or individually is time consuming, and there's only so much imagery that one person can look at. So Cerulean has used a machine learning approach to identify these on images across the globe. So Cerulean looks at an image like this, where we see a linear feature, which we know to be bilge dumping, or suspect to be bilge dumping. And what it's able to do is identify that feature specifically, and then pair those detections to satellite data about vessels to try and identify likely sources for those oil spills. That's what we see here. These pink dots are their AIS broadcasts. So that's a ship telling us how fast it's going. And we can match those up to see if we have suspected culprits. And looking at the previous images, you see these sort of single linear features. Obviously, oil in the water, no one thinks is good. But I think it really speaks to, there's a question of how severe is this? And one of the things that Cerulean is allowing us to do is illustrate that in a very real way. So what we're looking at here is oil fields off the coast of Trinidad. And at a period of time from July of 2020 to November of 2021, these are the slicks that Cerulean detected. And it becomes clear as you look at these things in total, how intense this problem really is. It's much more a death of 1,000 cuts than it is just sort of a thing we can ignore. SkyTruth made Cerulean data available for the public, for enforcement agencies, for activist organizations. I believe the URL is cerulean.skytruth.org. You can explore these yourself, and you can take a look at the areas that you care about, zoom into different areas, identify slicks, and see who we suspect may be responsible for those. So in collaboration with Cerulean, there's this other larger question of other industrial activity that takes place in the world's ocean. And that's where our Open Ocean project comes in. This is another collaboration we have with Global Fishing Watch, which is looking at the cumulative impact of the offshore oil and gas development industry. And specifically what we're looking at are behaviors and impacts related to two types of things that we see out at sea. Oil platforms, those are here on the map in green, and vessels, which we call FXOs. And these are industrial vessels that have been retrofitted or designed to operate like oil platforms. Earlier this year, SkyTruth and Global Fishing Watch released the first global data set of offshore oil infrastructure at sea. And one of the things that we found is that over time, the oil industry, in terms of development, has remained relatively stable. But industry sources indicate that FXOs, these large vessels, are actually the one, like as new infrastructure comes online, more often than not, it's an FXO than it is an oil platform. And that's why we're highlighting those as a specific type of infrastructure to look at. So there's this question of who's out there and what are they doing. So we're working to identify where these operations are located, but also who they are. So we're looking at publicly available data that's provided by vessel registries or ship tracking websites to see if we can identify the types of vessels or platforms that are out at sea, who owns them, how long they've been at sea, and any other sort of identifying information that we can provide that would allow people to monitor them or request enforcement in cases where they are not operating in a sustainable fashion. And so the behaviors that we look at to highlight around these, there's three main ones. So we're looking for evidence of chronic oil pollution, so repeat pollution events as we've been able to detect them from cerulean. So this is the platform here located and this detection of an oil slick associated with it. We're also looking at whether or not we can observe flaring. So as a part of standard operating for offshore oil and gas industry, methane is often flared off as a part of the production process. So what we're seeing here is Sentinel-2 multispectral imagery, Landsat and Sentinel-2 showing these flares in this sort of bright area. And the reason that we're looking at this specifically is not because we're necessarily concerned with the emission related to the burning or the flaring of methane, but this helps us identify the cycle of production that's taking place at these platforms or at these FXOs. And that gives us a better sense of what their specific individual energy consumption might be. And then we know that it's not just an oil platform. It's not just 1,000 oil platforms. It's also a vast network of vessels that operate around the world to support these or to transport their produced oil and gas around the world. And so what we're hoping to do is analyze the vessel traffic that's associated with these and measure the greenhouse gas emissions from all of these vessels cumulatively to really get a sense of what the full impact of oil and gas is on our climate. And as with so many of our products, we're trying to provide this to on the ground organizations that are working to protect areas that they care about. This is a graphic that we provided to a local group in Louisiana who's really trying to monitor Louisiana coastal waters for environmental threats. So we'll see the cerulean detected slicks here in purple, and then detected infrastructure or known wells in those waters. And they're trying to keep an eye on all of this to identify locations where they might have chronic pollution events. So I think looking at imagery is really cool, even when it's things that we don't feel good about. It's really amazing to see everything we can about our planet. But it's imagery like this, I think, that really helps remind us of what it is we're all working or all hope to protect. It's not all doom and gloom. There's a lot of wonderful stuff out there that we need to do our best to save. So with that, I'd be happy to take any questions that you all have. And if stuff comes up later and you want to get in contact, that's info@skytruth.org is our email address. So
is this imagery available online?
Yeah, so I should have mentioned that. So one of the primary focuses of SkyTruth's work is a focus on freely and publicly available data and imagery. I would say almost 99.9% of the imagery that SkyTruth uses for our research and analysis is provided by public agencies, whether it's NASA, the USGS, or the European Space Agency. And all of the output from our research looking at these images is made freely and publicly available as well.
Where would people find that?
You can, skytruth.org is a great place to find both our data and also information about where we get the imagery that we use. Yeah.
Sort of on question, like what's the business model? Do people pay you to research this and yet they let you put it out there for the public when you're done? How does that work? Do you use grant funds or?
Yeah, so
The
question is related to how SkyTruth funds our work. And so SkyTruth's primary funding comes from foundational grants, some of which are specifically geared towards individual issues. So for example, our work mapping hydraulic fracking in Pennsylvania, a large part of that was funded by the Heinz Family Foundation. Other projects like our mountaintop removal mining sort of come from general foundational support grants from organizations like Cornell Douglas. So it really depends on the project, whether it's issue targeted or whether it's more, or whether it's SkyTruth directed, how we work on it.
Don't you have Walmart funding something?
The Walton Family Foundation helped fund Global Fishing Watch.
Isn't that interesting? I think that's cool.
So, Chris, to that, mountaintop removal line section, that high wall.
Yeah.
Okay, so I had two questions. So mountaintop removal, because you said that it was hard to find imagery prior to the 70s.
Yeah.
Mountaintop removal is relatively new, right? So
Yeah.
I mean, when did it start?
So mountaintop removal is a specific type of surface mining. It happens to be the predominant type of surface mining in Appalachia. It's not the only type of surface mining. And as I recall, I mean, I think mountaintop removal mining, as we generally perceive it, probably started in the 60s or 70s. So it's been going on longer. And there are specific requirements for any mining activity that takes place after the passage of the Surface Mining Control and Reclamation Act. So mines that predate that often get classified as abandoned mine lands because there aren't the same sort of legal requirements to restore them. And so there's a whole separate project that SkyTruth is working on, trying to identify where those pre-SMCRA mines are. And high wall mining, as it relates to mountaintop removal, can be either an aspect of a mountaintop removal mine. It may be like an aspect of a mining complex, or it may refer to a surface mine from the 60s or 70s that was just a high wall that has now been revisited by mining operators like in the last 10 or 20 years, because with the advent of either better technology or an economic need for them to extract more, they've revisited older sites.
So when you get to the slide that followed it.
Yeah.
So the red line is the high spot or the lower?
Yeah, so
spot?
this is essentially a contour map, and we're using digital elevation here. And so the paler areas are relatively flat. And then these individual, it's sort of difficult stuff, but that red line in the center is essentially a sheer cliff face that exists on the landscape. So we're going from maybe an elevation of 2,400 feet to 2,200 feet. Yeah.
I'm sorry, you mentioned, in passing about the, if I remember correctly, about, the mines when they're abandoned.
Yeah.
Kind of get reclaimed. Sometimes they'll make, the companies don't want to reclaim, so they list them as active.
Mhm.
How do they do it? Just come back once a month and dig a couple handfuls of coal out or set up some equipment on there, so they don't have to restore them? How do they do that?
I'm not, so the question was specifically how companies sort of skirt those regulations on the need to restore. And I'm not well versed in that specific practice. I think essentially that the operator continues to list the mine as active. They state it's active, but production reports that are provided to state and federal agencies essentially illustrate no production on those sites. And so the question is, can those be identified? And that's one of the things. So we're providing high wall data to our partners at Appalachian Voices, and they have some specific regional knowledge about mines that are exhibiting behavior that they're concerned of. And so they're sort of putting those two things together.
How would you reclaim?
I was gonna
high wall
ask the
place?
same
Do
thing.
you actually like fix that sheer?
Yeah, so the question is how you reclaim high wall. There is a certain amount of slope regrading that can take place. But one of the things that we found is like, you don't need to do much. So you can, you put a little bit back on, you can spray sort of like hydro seed some of these sites, and they will get greener over time.
You say you don't have to do much, as in like, they don't have to do much, or to make a good ecosystem, you don't have to do much?
So the reason that these are, the reason that high walls are of interest is because they are the most expensive part to reclaim. And it takes a lot more to do it well. There's a lot of evidence of poorly reclaimed high wall. And that's something that we're trying to look at as well, because are these sites that have had their bond released and maybe have not been adequately restored? So that's one of the things that we're trying to illustrate or explore if that is an issue.
And when they are reclaiming, is it like often with native species or not?
Yeah, so the traditionally the practice for restoration on mine sites was not focused on restoring native species. A practice called hydroseeding was super common. Essentially, they come in, put some soil down, and just dump autumn olive and grass. So a lot of mine sites in Appalachia have autumn olive as a primary species coming back in. But starting in about 2004, there was a new approach that was put together by researchers at University of Virginia called the forestry reclamation approach. And essentially what it is a set of strictures about what you should do to the landscape to facilitate the recovery of a native forest on that site. And it's one of these practices which is becoming more and more prevalent, or has in the last 10 years become more and more prevalent. But again, it takes significantly more effort, and it is also sort of dependent on what the intended post-mining land use is when the permit is filed.
But is there a requirement that you have to go?
So to my knowledge, there's no requirement that the forestry reclamation approach has to be implemented. But I could also.
Are there at least like maybe laws against invasive species now? Or
I'm
yeah,
not sure.
yeah, something to.
Yeah,
Mm.
Yeah, funny, right, autumn olive over in Nacka, if they look for.
Yeah.
Yeah, so how does it work? Does Appalachian Voices come to you and say, hey, we're looking for imagery to help our cause? Or is it that you all say, hey, we've got some amazing imagery that we'd love to share with you to help your cause? How does that relate?
Yeah, so the question is how we would sort of land on some of these specific topics related to what we look at for mining. So it's kind of collaborative at this point. I am very fortunate to have great colleagues at Appalachian Voices who I talk to fairly regularly, and there's often sort of a back and forth, as SkyTruth being interested in facilitating strong advocacy. These conversations typically come up with, what is it you all are interested in working on? What's concerning you? And then we'll take time to explore whether or not we can provide that with the technology that we have. So more often than not, that's sort of happening. We chat, they tell us what they're working on, and we say, well, we can probably help you.
I have a couple questions from Zoom. So this one's like a two-parter. How many staff members are there at SkyTruth, and what's the typical educational background of your colleagues?
Yeah, so there are just over, I think, 20 of us now. So SkyTruth has grown quite a bit in recent years. And educational background, it's sort of a mix. So we have people who have more conventional computer science backgrounds, and a lot of them are working on our machine learning models. And we have a mix of folks as well who have more earth science or environmental science backgrounds. And so I will typically describe myself as a geospatial data scientist, because I have a lot more geospatial background rather than a machine learning engineer. And so, yeah, that's the general scope of our tech team is either CS or environmental science.
Yeah, it was one person doing the work at SkyTruth for many years, wasn't it?
Yeah, so SkyTruth was one person for at least the first 10 years. It got a little bit bigger around the launch of Global Fishing Watch, and then when Global Fishing Watch sort of spun off on its own, there were probably 7 or 8 of us. So it's fluctuated a little bit as some of the projects have evolved.
And then another question about how many clients you have.
I'm not sure how to measure that specifically. We have impact partners that we work with, and sometimes there are multiple, depending. So for the example of Cerulean, there are several organizations that we work with, as well as helping to facilitate storytelling being done by journalists. And then in terms of mountaintop removal mining, the data that we provide is freely available, but I don't know that we necessarily have a client for it.
What are some examples of ways that your data might be used in advocacy work? For instance, when lobbyists show it to legislators when proposing a new bill or amendments to a bill, can it be used in like legal cases?
Yeah, so the question is how SkyTruth data is sort of used to facilitate advocacy. So for example, data that's provided by Cerulean, and I forget the organization specifically, but there are a couple that are using sort of this information to push for better enforcement in certain areas. But it's also being used to try and, one of the intended uses is to help guide designation of new marine protected areas. So either to identify places that are at risk from chronic oil pollution, or to monitor areas which would be severely impacted by oil pollution. And then in the case of our mining work, so again, we really think of ourselves as data providers in that field, and our impact partners, Appalachian Voices, and they're the ones who sort of take data that we provide and analysis that we create, and they use that to advocate and work with policymakers on designing more rigorous requirements for restoration and things like that.
Have any of the abandoned sites become big solar operations?
I'm not sure if any of the old mine sites have become solar. It's something we've talked about looking at for a little bit, just haven't had the time to look at it yet.
Anybody else know that?
Mm-mm.
I know that West Virginia has authorized for some sites in southern West Virginia to be used that way, but I don't know if any progress has actually happened. It takes quite a while just for the engineering work to be done, for the permitting to be done, for everything. It's a couple of years before you even start seeing construction. So this was like just maybe a year ago that decision was made, so we might be seeing some solar in the future, but I don't know of any right now.
Couple more questions from Zoom. One is, does SkyTruth look at coral reef biodiversity?
So we do not, and I think this is one of the limitations generally for the work that we do, is that we're constrained by the surface of the water generally. So monitoring things like coral bleaching or biodiversity associated with reefs is difficult, but I think it's where data like what we create for Cerulean can be useful for other organizations as they monitor threats to coral reefs or to incorporate in their workflows. Sure.
And then another one, do you ever feel pressured by the companies that you're investigating to not publish your data?
No, we haven't, to my knowledge, ever experienced that. And I think this sort of speaks to our focus on transparency. So the data that we use is generally accessible to anyone. So it's not, we're not hiding behind a lot of methodology or like commercial data. Folks can go out and download it. It doesn't take much to see a mine is still not green after 10 years. It doesn't take much to identify, something like this on the surface of the water. So I think like that has really been a big shield for us in avoiding any kind of like industry pressure.
Sure.
Yeah. So
Yeah, two-part. I'm curious what aspects of like your work, stuff that you've done, one is like most intellectually satisfying for you, and then also that you're most proud of.
yeah. So I think both of those are kind of related to looking at post-mining recovery. So trying to design a methodology for effectively assessing how much vegetation is coming back on the landscape and how healthy it is it was a challenging intellectual process. And I'm very fortunate to have a lot of colleagues who are ecosystem scientists who helped me design that. But it's also, I think, the most rewarding to see these sort of data products out in the world. Like it's the project that I've worked on the longest at SkyTruth. So I think I just feel a pretty strong connection to it for that reason.
And it's close to home.
Close-ish.
Yeah, you ever get to ground truth, what you, SkyTruth?
No, I haven't gotten to ground truth anything, unfortunately.
That
You
might be a
just
little.
see what that really looks like. on
Yeah.
the ground.
Make a field trip.
Yeah, yeah.
Maybe then we'd get some scary pressure from corporations.
Mm.
Ground truth.
Yeah.
Mine in Central, and doing the start in Charleston.
I'm sure I mean, not. On
Yeah,
hand, yeah.
Circuit has been creating a nature preserve on the Mammoth Mine that recently has opened. It's not, I think, generally open, but any member of the public can
Yeah.
just walk in any day. But they have been doing some tours to show the reclamation work they've done. And before and after photos there would be like really fascinating.
Yeah, no, that the Mammoth Mine.
Yeah.
I haven't looked at that one specifically, but I knew that the Nature Conservancy had bought some some mine land and was working on it, so I'll have to take a look at that.
That'd be cool.
Field trip.
Yeah,
That's right, you're paying.
yeah.
It's sell school bus.
So I think one of the big issues regionally is flooding as a climate change thing. So could you use this data to predict a flood impact areas?
I think in like a very, in a broad sense, elevation data can be used to identify at-risk areas. It's not work that SkyTruth has really done. So again, for example, like, radar imagery is great for identifying that sort of thing as well. It's not work that anyone on our team has experience in. And similarly to a question that sometimes comes up is, whether we look at any humanitarian issues. And basically the takeaway is there are organizations out there that focus specifically on these issues who have a significant breadth of knowledge, and like they're much better suited to fill those data needs than we are.
Do you interact with those other agencies?
Depending on what the problem is and whether they feel like they need us. There haven't been a lot of instances that I can recall where we've had to seek them out.
Thank you.
Oh, your daughter gonna grow up to go to PVAS camp?
Oh, yeah. Yeah, she's already in the lit.
Yes, she's an advertising.
Thank you.
Yeah, that's what it means. Yeah, we kind of, yeah. So me, I'm afraid, yeah.
I mean, probably not here.